Alright guys, let's take a look at units and measurements a little bit. Starting off on the unit side of this, what are units? What are they good for? They give numbers meaning. Okay. For example, I could say, hey, I'll be back in 5. You have no idea when I'm coming back if that's all that I say. It could be 5 seconds, could be 5 minutes, could be 5 years, okay, it could be whatever. We have to have the units there because it tells us what our numbers mean and what they're doing. Two basic ways or systems of measurement. In the United States, we normally live in the Old English system, whereas the rest of the world lives in the metric system. And so units apply to many different things. You can see distance, volume, temperature, time, mass, force, and it goes on and on and on. So let's just look, real quick comparison. You can see what we're used to. Here's what they use in the rest of the world, the meter. Okay, volume, cups, gallons, quarts. Rest of the world, the liter. Temperature, Fahrenheit over here, Celsius everywhere else. Seconds, minutes, hours for time. Thankfully, it's the same everywhere else. Mass. Now, the Old English version of mass is a slug, and nobody uses that term anywhere. I don't think, anyways. The metric system version of that is the gram, and pretty much everyone is familiar with and uses the gram. In force, here in the States, we use pounds. Everywhere else in the world, it's the Newton. Okay, so in science, we stick with the metric system, and we use it because it's based off of, it's like a power of 10 thing. You always step in tens. If I start at the base, if I have just a meter, if I want 10 meters, that's a decameter. Or if I wanted 1,000 meters, that's a kilometer, right? A kilometer. Or I can step down from the meter. If I want 100th of a meter, that's a centimeter. If I want 1,000th of a meter, that's a millimeter. Okay. So let's really quick look at a couple of examples of converting units. Now what you can do here right now is pause this, solve these, do these conversions yourself, and then you can check your work against how I'm going to run through these. Okay, so starting here, we'll do this in yellow. Okay, how many meters are there in 24 kilometers? First thing you want to do is you say, okay, what am I starting with? Well, we're here, right? I've got 24 kilometers, and I want to know how many meters that is. Okay, the thing that I'm starting with is way bigger than where I'm going, right? Way bigger than the meter. And so if you look at this little staircase here, if I'm starting up here at the kilometer, I have to step down 1, 2, 3 times to get to the base. Okay, so that tells me that there's 1,000 kilometers in 1 meter, right? 3 zeros. So this is 24,000 meters. Okay, the next one, grams into milligrams. We'll switch to green. Okay. Or no, excuse me, milligrams to grams, right? I have 36 milligrams. I want to take it to grams, okay? Milligrams are smaller than grams. So my number, if I'm going to go to something that's bigger than I am, the number's got to get smaller, okay? So if I'm down here in milligrams, right here, I'm going to step up once, twice, 3 times. That means I'm going to grab the decimal place that's sitting right there, and I'm going to move it 1, 2, 3 times. So that's 0.036 grams. Okay. The next one is how many milliseconds are there in 3 hectoseconds? Now this is a weird conversion that you're probably never ever going to do, but we're starting here in hecto, and we're going down to milli. So that's 1, 2, 3, 4, 5. Okay, so I'm going to do 3 followed by 5 zeros. 1, 2, 3, 4, 5. And I can drop my commas in there. So now that's milliseconds. It's my final unit there. And then the last one, how many milligrams are there in 8 decimeters? I think you kind of see the pattern and you know what's going on here. Okay, so here's the answers in handwriting that can actually be read. Okay. Oh, look, there's a question mark. It doesn't even tell you. So if I'm going from deci to milli, I'm stepping down twice, so you should have 800 milligrams. Okay, in 8, or excuse me, I'm reading this wrong. Take a look at that. It says how many milligrams there are in 8 decimeters. Can you even do that conversion? Nope. Because I can't go, if you look at this, let me go back to my drawing thing. It's asking me to go from meters into grams. Okay? Those two units don't match. You can't do that. See, I almost made a classic mistake. I can't convert meters into grams. I can't convert distance into mass. Now, there may be some physics equation that allows me to do that later on, meaning that maybe I can run, I don't know, 10 miles, and I can burn off a certain amount of mass. Okay? But that's, you know, that's a little bit different activity there. Okay, so so real quick unit conversion. Can you add 12 feet, 3 yards, and 24 inches? Can you add that all together? And the answer is, of course you can, right? You just take 12 plus 3 plus 4, or 24, and you get 39 fitjerdens. No, I'm just kidding, right? There's no such thing as a fitjerden. This type of logic results in explosions, and if you guys are doing your discussions, you've read about maybe a couple of those. So you've got to convert the units, right? So I'm going to pick something that everything can easily be converted into. I can turn the 3 yards into 9 feet. I can turn the 24 inches into 2 feet. Add up all the feet, and I have something that makes sense, 23 feet. And if I needed to, I could take that number and convert it into any of the other things that I want. Okay. Now, if you're having a hard time converting methods, okay, we have this thing called the train track method, and it's going to help us out. It's going to make our life a little bit easier. So let me walk you through this. Okay, so the first thing you want to do is look. There's our train tracks. You see them? Write down what the number that they're giving you that you're starting with. Okay, I have 13.1 miles. And I want to know how many inches is that, okay? And so now I'm going to build a roadmap to where I'm going. So I have miles on top, and so I need to put miles down in the denominator next to it so that they'll cancel, okay? I'm going to turn those miles into feet. Now, if I wanted to, I could look up, and I could probably turn the miles straight into inches, but it's easier for me to turn the miles into feet. And then I want to kill the feet, so they need to go in the denominator, and I'll turn those feet into inches. So if you look at the way the units are set up right now, we'll fill in the numbers. 1 mile is 5,280 feet. 1 foot is 12 inches. So that you can kind of see there how the numbers fill in. And now I can cancel numerator to denominator, the units that'll die. Okay. And then that leaves me with the only living unit left is the inch, okay? And when you run your numbers into your calculator, anything on top you multiply by, anything on the bottom you divide by, okay? So we're looking at 830,000-ish inches, okay? So here's one for you guys to do. Your new field is 1.6 miles long. What would that be in kilometers? Okay, so if you want to take a second and see if you can run through this conversion by yourself. Now, I'm going to take a way crazy route to get to it, just to give you guys a little bit of practice and so that you can see what's going on. Remember, start by laying out a train track, map out your route, and here we're going from the Old English to the metric, okay? So here we go. There's my train track. You can see, and again, I'm taking a ridiculous route to get there. There's probably a shorter way, but it doesn't matter as long as I end up in kilometers, okay? Fill in, notice that everything is going to cancel nicely the way that I want. I would fill in those numbers, write the feet into miles I had from the last slide, feet into inches, inches to centimeters, centimeters to meters, meters to kilometers, okay? Now, these are the ones that are a little bit tricky, okay, is what do I do if I have to do a double conversion? What I mean when I say double conversion is if they give me a number like 15 meters per second, okay, that's a double unit. There's 2 units in there. And let's say that I want to translate that, and by the way, meters per second is kind of your standard physics unit for speed. And if I wanted to know what that is in miles per hour, we have to convert 2 units at a time. So let's take a look and see how that's done. Again, I have my train tracks. I'm going to write down what I'm given. Now notice how I put in the 15, There's the 15 meters per second. Okay, so you see that second goes down in the denominator. And now when I go to map this out, start with your top unit. And really, it doesn't matter what unit you start with. I normally start with a top unit, and then I'm going to worry about that one first, and then I'll go back and take care of the seconds later. So let's start with the meters, okay? So I want the meters to die, so I need to put meters in the denominator. Let's turn the meters into feet, because that's fun. And then I'm going to turn the feet into miles, okay? And now if you notice, see what, fill in our numbers. Okay. Meters die, the feet die, and I'm left with a mile. So if I stopped right now and I did the calculation, I take 15 times 3.28 divided by 5,280, and I would be left with miles per second. But that's not what I want. So I need to kill the seconds. The seconds are in the denominator, so to eliminate them, I'm going to have to put them in the numerator. So you can see it there. I'm going to turn the seconds into minutes, and then I'll turn the minutes into hours. Notice how my units, we got to fill in the numbers. Notice how the units cancel. The seconds die, the minutes die, and now I'm left with hours. Okay, and so now when I run through this calculation, multiplying by 3.28, dividing by 5,280, multiplying by 60, multiplying by 60, I will be left with a number in miles per hour. Okay, and that is a little bit about unit conversion. There are more examples in the book. Check those out, and if you need any help, either send me an email or write something on the discussion board. Thanks, guys. Good luck.